So we're live. Okay, so last stream was sorting out the engine graphics API. I think we're still finishing that up. And then we are going to try and get the game logic to be on a separate thread. That's the plan. But yeah, so basically we're in the engine graphics C file. We're currently looking at the voxel cache upload stuff. We've got to make that work with the new graphics.h API, which we made last time. So we have this payload filled with all the render data, and it just holds like all the voxel models that you want it to load in, and then the model instances and stuff that you want to render. So yeah, cool. We just got to get that on the GPU, and then from the CPU side, we're able to push. Sorry, from the game thread side, we're able to push data to the renderer, which is cool. Awesome. Right. Start with a quick prayer. Then we'll get going. Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you, Lord, for being our great provider, providing us everything we have, the breath in our lungs, the food we have every day, the warm showers, the our cars and other material things that we have, and also our family, of course, that we still have. And not everyone gets to keep their children as long as we have, or their parents. So we just thank you for that. Yeah, Father, help me have a good day today, good time streaming today, successful time. Help me sure the work that I'm doing yields fruit, and also pray that each one of my viewers have a good time as well, hanging around. But also pray that every one of my viewers gets to know you, Christ, someday before it's too late, and be saved. And I just pray that if there's any problem they're suffering with, Lord God, in their life, any illness or anything they're struggling with mentally, Lord God, help them solve that problem and let them see the hand of the Lord in their life. And we just thank you, Lord, for all that you do. In Jesus' name we pray. Amen. Cool. Right. So if we take a look at voxel cache upload, so every frame we need to upload all the instances, and then we also need to upload, we need to upload all the instances. So it uploads all the change in models. So we changed the models such that it no longer is an object pool, because the object pool is on the game side, and the game side controls like what models exist and don't exist, basically. That's the way I've decided to do it for now, because it makes the most sense. But in the future, it can always change. So here, we're just going over all of them and uploading them. So there'll be a range which has changed, and we'll just upload that range. So we go over all the models in the array, and voila, something like that, yeah? Now, instances. So basically, you upload a full amount of those. So I guess we can just, so the count is, just get rid of that for a minute. So model instances buffer, the start index is 0, and the count is, do we have multiple count? We do. Okay, so we'll do a little local. So that'll be GFX, render. All right, it's one of those. Model instances count, yeah? Okay. So hang on a minute. Why am I doing an offset on these? This set looks incredibly wrong. So the byte view, yeah, there'll be a CPU offset, and that must. Oh, you manually have to do the offset yourself? No, that doesn't look right. That'd be a silly. Yeah, this is completely wrong. Oh, this would have been bad if we had more than one. So what's going on in these in the rest of the uploads then? So essentially we have an offset that we say in this buffer offset the destination is an offset into the buffer. Then for some reason I'm offsetting again. Oh, not in this. This one's fine. Right, yes, in the voxel cache is the problem. Okay, so yeah, these. Oh no, that's right. These are right actually. Right, but it's only this one which is wrong, the voxel model, because it's, yeah, it should just be v data. And that was really silly. That was really, really silly. So, man, what's going on here? This is completely dumb. So dumb. So source models is the start plus the index, and then the destination array is just the index. Right, that wasn't changing at all in the loop. Oh, that's like the most dumb code I've ever seen. Right. Oh, man, I'm not sure what I was thinking when I wrote that code. Could you imagine if it was more than one person working on this project and I Git blamed it and it just pointed its finger right at me? Man. Terrible code. Cool. Right, sort that out. So, so let's fix this problem then. Right, so we're going over all of these model instances, and so the destination is allocated. Let's go. The source is going to be a graphics render voxel model instance. Let's go. So that'll be in graphics render. So these are given from the CPU, the game thread side when we have a game thread. And we essentially just throw them in here. So that'll be a model index, the world from local. Now here's the material stuff, right? So there's a thing called like a material palette and all this. Right, we're super close. Getting this done, this is cool. So we've got one more problem, that's the materials. Then they've not been uploaded. We'll talk about that in just 1 second. I see a different problem though. Right, let's get rid of that. Voxel models store memory. Yeah, so it might fail to store. That's another thing, isn't it? Cool, we're getting close. So the number of ones to render, well, that's in render. Yep. Right, it's sort of the new problem. All right, so the new thing is this voxel renderer is like the prototype code, right? So we can like put in basic models, and then we can also make them a little bit less basic as well and provide some more defined models that give away what things are, so we're not just looking at a blue rectangle, a blue cuboid or something like that, right? Or sphere means this, right? So that's the plan, right? So this is mainly to help with prototyping. So one thing I want to do is have the ability to pass up these materials. So these materials are just, we have the ability in our renderer to like do procedural materials, so 3D materials at runtime, but it says like custom shader code. But obviously, I don't want to be doing that while we're on these assets. So I've just got a hard coded sort of solid material, so a solid color material essentially. So it's just got the diffuse, specular, emissive color, and all that in there. And the way we would do materials is they kind of go into they go into like a pool of materials, and then you get uploaded when needed, right? But because it's a prototype code, we might want to like change these all the time as well. Have some. This is like a pulsing box or something, right? So you scale the emissive strength and you get some animation, right? So we kind of want to just upload those every frame with the model instances that get uploaded every frame, right? It shouldn't be too bad. So the idea is we should probably in the material cache go over all of the model instances, and then what we're going to do is just allocate them in a sequential order, and then we can simply reference those from the model instance, and it should just work out. So we're going to put in some hacky code which goes around our so I've got material cache here, right, where it allows you to literally allocate and deallocate different slots. Well, we're not going to be using that at the moment. We'll have another in the upload. We're going to sidestep that stuff and just go over all the instances and just do it that way, I think. Yeah, so we'll do an if one, and we'll say this is for prototype. For the prototype graphics voxel renderer, okay? So when we do the I think we'll take this. So we can do a core object pull clear. Can we do a clear? I like the idea of a clear, to be honest. Reset. Oh, we have one of these. How do you clear it? Like, it would be cool. Yeah, let's not even bother clearing it. Let's just play pretend. That'd be really silly. What could we do? we could do... So ultimately all we need to do is set the memory. Where's the memory going to be? Cache materials pool entries. There's obviously 4 entries per material instance, right? This is all we need to be setting. And then the property words buffer as well. So that'll be VK material. Let's call it M, yeah? So M pro material index, or we can figure that one out. I think it's graphics VK material. Was like one of those V0 ones? V0. Oh no. Oh yeah, pro material, that's it. Pro material solid, yeah? So hard coded. The word block and all that. I guess we can hard code that as well. So the name hash, we probably don't need to care about that. Is how does what window it get? You check if it is allocated or not. We can probably memset the bits. Yeah, let's just hack this code together. So or we could just do another if code basically. So I think we can just do some of this basically. And we'll just return id.raw and core object pull id mask. Return, sorry, address of cache materials pool entries. Right, just completely go around the system. And we're just going to set the data accordingly. So with the property words, I think we could... Well, we could just set the pointer because it's just an integer, right? Easy. So, yeah. But it would be nice to preserve as much code as possible so I don't have to chase it around. Yeah, let's... The materials capacity, maximum number of materials. Now this number should be 4 times the amount of instances, right? So we should be careful of that one. So yeah, so I have about 1,000 instances. Maybe that's not enough, but we'll do that. Probably do 4,000. Hey there, Colonel J. Welcome, sir. How you doing? Welcome, welcome. Hope you're having a good day. So go up to 4 materials. times 4 plus mi. That ought to be good enough. Yeah, then we'll say this dot start equal. So there is a where are we putting the property words for these guys? Call it offset. So the property words would be size of v0 solid material, something like that. Yeah, solid material. Now the problem is that's got that header thing on it, so we need to get rid of that, and that's the number of words, isn't it? Sorry, that's the number of bytes. Yeah. So then it'd be divided by. Great day, thanks. Awesome, good to hear. Good to hear. For me, it's the weekend, basically. You know, I'm off. I don't work Fridays these days. So I will be streaming tomorrow as well. I've got some other things I do as well. But I'm going on holiday next week, which is cool. So I'll be preparing for my holiday as well. I don't quite say where I'm going, but I won't be streaming next week. Basically, I won't be. So this Sunday to the following Sunday, I won't be streaming, including those days. Yeah, gonna be cool. Right, let's just jam this hacky code in. Right, any other things that we need? We need to obviously copy the properties over. So cache property words, you got the prop start index, and you're just gonna set the 4 different property words. So where do we get the material from? So we'll call it, I can just call it source or something like that actually. So it'd be graphics render material, it's called. It's just a hard-coded solid material. Let's call it RM, I guess. So that'll be in source materials mi. So plus 0. So the word is just a U32, right? So the diffuse word, specular word. Yeah, you've got to do some packing and stuff like that, you know. Instead, I could do a V0 solid material. That's what we want. RM diffuse, RM specular, RM gloss. Right, so that will be an SM. Then we can just mem copy. So core copy element many. The destination is going to be here. The source is going to be from SM diffuse, which is the first field, past the header. And then we do size of, hang on a minute. Sorry. Words count, completely messed it up. So that'll be index times words count. Times 4 plus mi times. Right, I think that's the code. Super hacky, but it's going to work. That'd be cool. So we just need to change these words start index and all that, right? So basically this is 0 and this one is basically count times 4 times by the number of words. I think it's something like that. Right, let's analyze this hacky code. Right, so ultimately all we need to be doing is fill in a properties buffer. We need to be changing the graphics material such that the pro material index is set and it has a pointer to this blocks thing which has this start variable set to the offset into the properties array, such that when we ask a function later on to get us the GPU handle for it, it can do that, right? It doesn't do much, right? Now, okay, so DST array wouldn't do any of that. So the material cache, we're just going over all of the voxel model instances. It's going to store per instance material data, and we're just going to throw them into the material cache, just into the memory directly, because it's for a prototype voxel renderer, right? We don't really care about it being proper as long as it works. So we do 4 materials per model instance. The properties start index is the instance of the material, the index of the model instance, times by 4, because we've got 4 per material, then we add the material index. Multiply that by the number of words per material, and so a word is a U32, or how many U32? So there should be 4 of those. So your material is just instance times 4 plus material index. Then we set the right proton material so the right shader runs. We set the blocks start to be the properties start. We set that pointer in the material so it works. It's just a static set of blocks. We read the material given from the game side. And the game side, I got this diffuse, I got this specular, I got this emissive. And we just encode that using the code generated bit packing code. And then we copy 4 elements, right? That's what that would be, is 4 from the start here. Yep. And voila. Then after all that's done, we say this range has changed such that it can such that we'll upload the property words, which is basically all we need. Nice. So then going back to here into the voxel render, sorry, model instance, if we see there's this, so 4 materials, and we see there's a material cache get, so we have to, anyway, we don't even need to do this. We can go around this completely. This is amazing. We can just get the cache. Oh, come on. So the cache, what are we doing? All these 2 things called index. That's not very nice. So call it mi, I guess. So cache, so material cache, then mcache, mcache, materials pool entries index times 4 plus mi. And we take the address and that will compute the GPU handle which the GPU wants, right? Which we program the system for. Cool. Right, so I think that's mostly it. We just got to go around now and... Oh. Yeah, just fix the rest of the compile errors. There shouldn't be many. Right, so voxel model, what you complain about exactly, let's keep going. Right, we'll get rid of these IDs. I think we can probably get rid of a lot of these. Oh yeah, we don't have any of these hard-coded things anymore. Let's get rid of those. Nice. Because that'll break the system if not. Right, so this is just some voxel cache frame init, voxel cache upload. Yes, that should do it. Hang on. Yeah, when do we store this store memory stuff? Yeah, we should actually be doing... We haven't called these functions yet. Alright. Hang on a minute. So... the CPU side code can be like, hey, we've got some new voxel models I want you to load. Right? So we need to get those. Render voxel model. So source render voxel models index. Now here's where the fun begins. Now we've got to switch on the type, the kind, shape is it. So there's a few different shapes. There's a voxel shape. Oh, there's a box and a sphere. We can programmatically send that into graphics vk voxel cache store shape. So do our model index, which comes from source model index, the shape source shape, and the dimensions, which again comes from the source thing. Yeah. Now there are different ones. They're actually, you know, maybe we can call into this guy. Nah, just keep it like this. So there's 3 ways we can get voxel data. There's like basic primitives that we just programmatically do CPU side and give it to the GPU. There is also from memory and from a file. So from memory, there's another one. So the from file and from shape actually call the from memory one internally, but they just do some extra stuff to get into memory first. So the path here would be source file name. Yeah, that's gonna probably... So to build the path, we've got to smprintf that, you know. Path, size of path. Now, basically we have one of these ones at the moment. It's the cross. Run out loud. So we just did a cross, right? It's just a little custom file that we parse. So we can at least do our own little custom assets and stuff without having to do like image files or whatever. It should be quite easy. And we want to make that hot code reloadable as well at some point. So assets, voxel models. That's where it lives. So it's assets, voxel models, then whatever that is there, yeah? Easy. So that fixes that problem. And now this needs, there's a word start index, and then there's a, yes, there's two different images that need to be made. There's a bit set for the voxel exists, so 1 bit for each voxel, and there's a materials as well. Now I've passed in an index, I need to index an array. So there's an array called graphic G, GFX, VK, render, voxel bit sets, this one. We just got some start indices into that array basically. So this will allow us to programmatically define some custom voxel models. So my current thinking, where this would be useful, is say we have some terrain and we want to build like a little custom terrain model. Well, you just programmatically generate that and send it to the renderer. Voila, right? Not difficult. So yeah, that'd be cool. It's getting a bit dark in here. Right, so that's that one done. I'm glad we sorted that out. Cool, what's next? So this is all the materials and stuff. We'll just comment that out. Grass blade. Oh crap. We can just comment that out as well. When we get grass working, we can look at that again. Yeah, it'd be cool to do grass. Grass again, wouldn't it? Right, so this is the material cache stuff. You know, we can just comment this out. Keep it in there, it's fine. All right, lovely. So there's the graphics side supposedly done. So let's check the game side. Okay, so we have hard-coded, we have the cross model being loaded from a file, and we also have the voxel model here, and we have two different materials, right? One's glossy and a different color, yeah, and one's rough. So if we go and run the build script, hopefully we see some, right. At least it compiled. Just didn't run, but that's okay. So graphics render compile, I forgot that function is now. Oh yeah, this one. Yeah, I'm not sure if I really like that name. But why is render compile doing like a create a... That was interesting. So this is different, right? So this is saying code modules game. Right, what is trying to do a code modules game thing? I'll run.bat. Yeah, can I inspect the... Because I've moved stuff from modules game now. Interesting. What's generating that path? It might be from my time in the build system. Just delete the build and see if that pops up. But yeah, what was this complaining about? So graphics render compile. So this is so essentially from the game side, you basically keep pushing to this payload and it's like a void buffer, and afterwards you compile it into like just separate arrays, basically. So it just means we can just do one allocation, not have all these different allocations everywhere, and then temporary allocate when we know the sizes exactly, right? Now, and it also means we can pass more data to the renderer, and the renderer can decide what to evict if it doesn't fit in the GPU buffers. So it can sort by screen and do that stuff, right? So it's complaining 67 here. Bum bum bum. So when we try and mutate the structure, weird. Like, that's really dumb. Why should 67 be complaining? Because this is literally like... Oh, it's a pointer. Who? Incredibly dumb. Right, hang on a sec. Let's just sort that one out. So it'll be gfx vk render dot. Right, so this is going to compile everything now. Interesting. So I was trying to run the old... Yeah, I think we should change it back to game. I think so. Let's just go to the build script. I called it engine. I don't know why I did, but yeah, we're going to call it game because it's basically just... So in the apps, we've got a thing called game. It's just the main function, right? And it's specifically to do the plugin stuff where you can like hotcode reload. But I thought, yeah, I kind of reorganized it. So I've got a games folder now. We got the game library, right? So the game library has all the stuff about the game in there, like everything game code is in this. It's going to be in this directory. So the apps, we'll call this game now, but this is just the main file, right? Where it literally just does the bare minimum to load the DLL for the game and just run the loop, right? And if it checks if it needs to be reloaded or not, basically. And reloads the DLL again. So let's try that. Hang on, I need to probably delete the build directory. Cool. Right, this time it's in 1837. Went to 39 there, 1830. Oh. OS pack. Also, OS packet's not being set to an actual OS packet. So what an OS pack is, it just basically holds a snapshot of all the input data from the OS, you know, mouse, keyboard, gamepad, the displays, where they are and all that, right? All the information we want is just in there. So basically, from the game side, the OS packet is not being set. So we put it in the game world, and Yeah, I wonder, can we clone it? Yeah, you see, I wonder whether we should just... Yeah, I want to make a clone. That'll be cool. Or copy. Not sure if I should call it clone or copy. Clone is probably better. Clone means... Yeah. Yeah, I guess clone basically means you're taking a complete copy, right? You're not really doing any sub copy, right? I think maybe clone is probably the better language. So we can get rid of that comment now. That's the cool thing. It's always great getting rid of comments because comments suck. So you basically want to go to the packet, right? Yeah, to packet from GOS packet. But is this really going to work? Because GOS packet is modified based on like... Oh, that gets modified when you use the event thread. Oh yeah, no, sorry, when you read from the event thread. So it's fine, it's safe. But yeah, so we just want to change this to DST. In a minute. Nice. So now I've got this guy, which is cool. So from the game side, yeah, I wonder if we want to... Yeah, so for now we could take a complete clone, but in the future we could. Yes, we could take a complete clone into the graphics payload so it kind of owns it. It's not really the best thing to do. So maybe we can keep them. We can keep maybe so many around such that we can keep them in cycle and just pass pointers to them, which would be far more efficient. Just make sure we recycle them when they're really done with properly, you know. But for now, we'll just copy it. So that would just be a OS packet clone. So the destination is graphics payload. And the source will be from the game world. To do, can we avoid doing a clone? There we go. Simple question for future Henry. Okay, so that means then, because we've dropped the pointer, it is going to actually... And we have to change that. Okay, it's only used in one place. But there we go. Cool, so now... Oh, okay, it's changed in another place. We take the address there. Cool, cool, cool. Here we go. All right, so it's complaining the clone. Probably because it's never initialized. So we now need to initialize the packet. So oh, we have something. It's oddly that color though, you know? We've probably got the instance inside the... Yeah, the sky's been rendered okay. So we've probably just got the instance jammed into the... No, it doesn't look like we're rendering anything. Alright, let's investigate. Very bizarre. So, what have we done? Good question. We have... So we could get render doc out. That's a way of doing it. So we've got an instance, we push on an instance. But the camera is outside, right? I think. Like the camera is not generally looking there, you know, if we run it... Oh, failed to read the cross. Interesting. So that's part of the issue, you see. It's failed to read cross. So it's got invalid memory probably, so... the voxel models... .txt. Why is that complaining? Assets... Oh yeah, because they're not copying them over yet. So we need to say ... This is inside the build folder. Alright, so it's read it now. So let's investigate through renderdoc. Yeah, the colors are a bit different. I think it's because it tries to do SDR or something like that. I forget. That's not it. So we're rendering one model. Let's do the mesh viewer, bunch of NANs. Cool. Well, there's an answer. So we've got a whole lot of NANs. So the question is maybe why? We could probably try and run the thing and see where it comes from. Maybe, I don't know. We could probably better off inspecting the data rather than trying to I don't know why I've not got the disassembly working. Probably something I'm not doing right in my build. Yeah, let's look at that. Is there anything... Let's go into the build system, GLSL. So what are we using? GLSL C. So there's probably a -G we're missing. Alright, let's just get in there with that. -G. Try that. So that's probably why. Okay, so the other thing it was... We've got the model instances. So it's uploading... Right, so it's got the world from local matrix, got the model instance, spacing is 0, the material, different materials. Yeah, there's only one material in this. It seems like it's setting some stuff correctly. I don't know about all of it though. So X, Y, Z, W, X, Y, Z. Oh, sorry, it's X, Y, Z, X, Y, Z, X, Y, Z. Yeah, that's right. So it's got one along each of the, so one X, one Y, one Z, right across X the axes vectors. Looks pretty identity to me. Although, what is this complaint? So the translation is 000. Yeah, and that's the inverse. It's pretty alright to me. Right, so let's go ahead and find, yeah, let's recompile that. So I want to try and see if that debug info can be a thing. So I think this will run it with debug info. Right, no compile errors with a -G in there now. So we can try render doc again. Right, I think it's, yeah, cool, it's got it, disassembly. Oh yeah, it's cool. So, right, so you get yourself an instance and, you know, it's got an axis and all that, right? So, when does it become, you guys might not be able to see this very easy, so let me move it here. Right, constants and the variables. Right, so B is 1. Right? View space 000. Interesting. Oh yeah, will be that. Yeah, of course. So oh, got some infinities. Is that right? Let's look at that function. So it's projection from view calc. Near clip. Yeah, there shouldn't be infinity, right? Near clip distance. Scene dims. Yeah, 1 divided by, that would have been a 1 divided by a 0 then. Yeah, yes, that would be 0 for some reason. Why is my near clip 0? What are you doing? Ah, payload camera field of view. You're not being set properly, I don't think. You're right there, though. Where's the camera coming from? Oh, we're not setting the camera at all. G payload camera. G game world camera. I think that's what's not going on. Isn't that meant to be like a sun direction as well? Right. Yeah, we forgot those. That's the problem. Here we go. Bam. We're in business. So unfortunately, the cross is kind of black at the moment, but we've got the two different materials. I don't know why it's black. So let's analyze that a bit. Yeah, the sky seems to be working. Right, so these are the colors, right? So you've got a gloss, emissive strength is 0, but obviously the second one shows up as purple. So red, green, blue. Interesting. So red and green will get you so red and blue will get you a purple, right? So, but this is 2, right? We saw by here 2, right? 1 should be purple, and then the other should be green. So we saw in my previous image. So I think they're the same colors. They seem like it. Something is off. Now we could just go over to GPU land. So we just literally find scene, graphics material. We'll find solid shade. You can put your lovely if statement in there. Right. If is mouse at shading dot screen debug screen coordinates, something like that. Print 0x1 s dot diffuse. We'll do that. Yeah. So obviously it's getting black here, then here it's getting a valley. You see here it's 0.5 there. So that means it's getting the wrong. Seems like I've gone off by 1 error. Somewhere there's an off by 1 error. So we can start analyzing this. So where's the word start index? So this is the properties where they start in the material buffer. These start at 12, this starts at 0. Right? So 12 is a bit wrong as well. 12 is too many. 12, like, that seems to be in the number of bytes, right? As in 4. No, it's not in number of bytes. Yeah, there's something really wrong there. But anyway, this shouldn't be 0. This should be probably more like 4. And this should be 0. That's interesting. Let's have a look around what's going on. So it seems like CPU side, when we did our super hacky code, for the material cache upload in the meantime. What's going on here? So index times 4 plus times the number of words. Right, so maybe we just get in the debugger here and see what's going on, maybe. Because that will probably be the easiest thing. So we could pop into Red debugger. And what we're looking for. Yank that to the clipboard. Alright, let's pop in here. So there is 4 as we expected, right? 4 words for the solid material. Now, the first one. Right, can I view that in like hex or something? Well, maybe not. Well, I can easily do this, right? Right, so it seems like it's got a bit of blue. What's going on there? It seems wrong. Oh, E is 2 bits as well. Yeah. So it seems like it's got a bit in the... Yeah, it's 10, 10, 10, 2. That's the color thing. So there's 2 bits at the end. So yeah, a bit in the blue and a bit in the red. So that's your first material. Right. So maybe this code is correct. Maybe it's the mesh, sorry, the voxel model instance when it's trying to actually set the material index. But anyway, let's keep going. Right, so it's going 4. So the diffusers, something like that. Yes, that's a definitely different color. That's fine. It's a... Okay, this is cool. This is fine. So there's the voxel model upload. Where are you at? Here, right? So this is the one I'm interested in. So we're doing get the material. The start is at 0. Cool. That's your first one. Your next one. At 4. Yeah. Okay. So it seems like the data is fine. So it must mean then... Ah, you know what it is? We might not be reading it from this palette in the renderer, I think. So scene shade. Oh yeah. Oh, okay, what's this? So this is the scene shade pass. So we've put into the visibility buffer, we're now shading. And it's got 4 layers of visibility buffer for order independent transparency. Now, right, we are loading from this buffer, and maybe the material index is wrong. So if is mouse at, have we got one of those? Yeah, let's take that. So what is the material index? Right, we're super close now to narrowing it down. So that will be... Right, it's got a 1 there and a 0. This... Right. And also, wouldn't it... Yeah, 0 and a 1. That's what we want. So... Interesting. I don't think I can tell anything with this, can I? Right, so this is saying 0, and this has got something else. Right. But it does seem like the value that's been uploaded to the GPU is wrong. Huh. We just looked at the CPU side and it was right. DST. Oh, we're using the wrong index, that's why. MI. Ta-da! Look at that. There we go. Right, so from game side now, we've achieved it. So what we mean is in game, in the game logic, you can do stuff. You can render things. So for instance, you could change the emissive. Let's give it some emissive, right? Just make that super emissive. And we'll just say over time, we'll sign every frame. You can even change the material and make it look different, that sort of thing, right? So it's going to be really emissive. Is it? No. Don't do this to me. Why aren't you doing it? Oh, it is changing, but it's not enough, I think. Okay, reload is busted. Let's just sort that out. There we go. You see it glowing. And it goes down. That's all controlled from the CPU side there, as it uploads every frame. Nice. Cool. Right. That's awesome. So the next thing we want to do is make it such that we put stuff on different threads. Right, what have I changed? Right. Yeah. So we could probably commit this code, but I think let's move the thread around as well. So I'm thinking, no, maybe we will commit this. Yeah, let's commit this just in case, and then we'll move it around. So we want to do what we was talking about last stream, this guy. So you have the event thread that does a frame, where it records some input, puts it on a queue somewhere. Then when the game thread is ready, it goes, hey, I want to do another frame. And then it, simulates the frame. And then it, at the end of the frame, queues up some data, sends it to the renderer. Right, then when it's ready, it takes that and does a frame. Right, and so on and so forth, right? The renderer then sends it to the GPU and it actually renders, and then the display gets the image, right? The lifetime of a frame. So we want to be doing this, or we have a render thread and a game thread. So we want to make it, so we've got the system now, which allows us to like make a payload, clear it, and then like push some stuff on and then render. So we need to be able to basically double buffer these payloads and give one to the renderer to use while the other one gets populated by the CPU side. That's what we want to do now, basically. But yeah, I'm just going to take a quick break. If any questions, feel free to ask away and I'll answer them when I get back. BRB. Right, welcome back. Right, can I like press the secret button? Right, I'm back. Alright, you didn't hear me the whole time there. So I just commit this basically because yeah, I was just double checking it wasn't leaking anything, that's why I put the secret window up. But yeah. So now we've got a commit we can always roll back. So from the game side, we've got this sort of game main file essentially. So we want to try and achieve this. Game thread makes stuff at end of frame to give to renderer. So the basic idea is we need some payloads. Now the game should probably control the payloads, right? So inside the game, we'll have a graphics payload. We'll probably just have two. Hey there, Captain Chica. How's it going? Welcome, sir. So, graphics payloads in some global state. Oh, yeah. Now, you'll probably have a graphics payload or a render index or something like that. Graphics frame index. Or you can and one it and get your thing. Easy peasy. Yeah, so, you build up the game and you go game. Where's the game in it. Where's the game in it? Well, the game needs to initialize. Like, could you want more than two payloads? Well, you could have two. You could allow the renderer to like queue up. Yeah, I don't think we really care about that. But we should make a constant anyway. Graphics, game graphics, payloads, capacity, or count. 2. Hey there, Saladine. Yes, Helix. Good eye. You spotted Helix. Usually people just think it's Vim or something. But yeah, Helix is the way. Well, sorry. Jesus Christ is the way, the truth, the life. But Helix is a great editor. It's much better than NeoVim and Vim. Because the config file, right? Get this, it's revolutionary. Is just a config file. It's not a programming language. It's not thousands of lines just to configure basic stuff. It just comes built in with all the stuff you want, and you just change a few things and it's usable. And when you update it, it updates. No status line. Yeah. Fair play. Cool. Is this a skill issue or is just my opinionated observation? But C code is harder to understand in regards to architecture and what's going on from scratch, harder to not mess up architecture than Abomination of C++. You think so? I think it's the other way around. I think C code is like dead simple, you know? What do you like stick stuff in classes and do OOP style? Is that what you do? Like for me, right? Like look, like this is my core stuff, right? So here's a stack, right? So it's like a standard vector, right? You just look at it, right? You got a void function for each of the things. You pass in the element sizes and that, and got some macros to help, you know, pull it off. Pretty simple. Right, node templates, just some void functions, does the thing. Super simple, super easy, not complicated. And you're not wrestling with any of the silly C++ stuff, you know? Less language stuff. You know, this is a multi-consumer, multi-producer queue. All quite easy, quite simple, right? You got hash table as well. Yeah, just functions and structures is all you need. All you need. Easy peasy. Let's go to the graphics in it. Wanna be with you. Global game, payloads, index, payload spec. Let's get the payload spec in there. Let's do like a megabyte of render data, and voila. Right, so now we've got those in the global. So the basic idea is we need to kick off the game logic thread. Does it? Right. You know, in the future, I'm thinking not having a dedicated thread and it all just goes through the job system. But for now, threads because we're prototyping and it's the easiest thing to do. So basically in gaming it, after you've initialized everything, you just send off the OS thread in it. You do one of these guys. Now I got a spec. Let me just find another one where I've done it. Yeah, here it is. Right, so we're just gonna launch a new thread. We're gonna give it a name of game logic. So game logic is the name. The argument is absolutely nothing. So what do you want exactly? Is an int, isn't it? It's an int. I think. And avoid star for an arg, I reckon. I think so. So while one, and I guess we can exit at some point. I don't know, but today I had to rewrite some old piece of C code, and now it's all of a sudden structures have vtables. I don't know, I very, very rarely use vtables. Like, you know, when you use like Rust, you feel like you can make everything into a trait. But then like when you actually use C code, the amount of times you really need function pointers. Like I always find function pointers to be quite a bad design usually. And I only really use them when I have to. Like when I interface with someone else's code, right? I think that's basically the thing, right? When you interface with someone else's code, function pointers for the most part. Like, for instance, there is the game main where I got function pointers here, but this is just because I'm doing a sort of a plugin, Poco Reload, a DLL, and then the Vulkan code, right? And then other than that, I try and stick away from function pointers as much as possible. Like they are used though, don't get me wrong, but just in terms of like a vtable style, yeah, very, very rarely use them. I have a software question. I need some advice, and I can't find any. That's right. You go and ask away, sir. Yeah, what would I use a V? You know, like some people, like in Rust, for instance, you have like those like read and write traits, don't you? You know, like, and they implement those for files, memory, and networking. But like, when do you really write some code where you maybe would read from the network or maybe read from a file, and those traits will be super useful? You know, you just do a switch statement, right? Uh, if you really needed to do that, and you basically never want to do that because, right, in general systems like that, like usually has, you know, typically when you want to write to the file system, you want to write to the file system, right? You don't really want to maybe then write to the network. Unless you're in like a virtual file system, I guess. But again, you can just use a switch statement for that. They solve very, very few problems that you actually run into, these vtables. A loaded question. Very minor software related. On Facebook, I've been coming across a lot of malicious things that I feel they can prevent, but have actually promoted rather than prevent. I come across a sponsor ad on Facebook called Stalk AI, and they advertised itself as a how to avoid the FBI and how to dox people. How is this legal for Facebook to sponsor an ad like that? I don't know. I have no idea. Yeah, I'm not sure about the one where it's about how to dox people. I don't know how legal that part is, but you know, um, there's lots of laws and things which is about trying to keep the individual, like separation between, you know, the state and the individual, right? So, you know, and education on stuff like the laws and police and how they can, what rights they have and what rights you have. So, yeah, I don't know, but if you're promoting crime, then that's obviously a problem, right? Yeah, so it's called Stalk AI, but I guess what it means is anti-stalk AI. It's just a terrible name they've chosen. Right, how to avoid the FBI and how to dox people. Yeah, I don't know. But yeah, I don't know. That's the thing with law, though. Lots of it is kind of has to be decided on a per case basis sometimes. Because there's like, the line is usually a bit blurry or where that ends, start and ends in law. Because things are complicated. But yeah, it's not really my area of expertise, though. Hmm. Maybe. Right, so where's this thread going? I guess we'll just chuck it in the game dot logic thread. So we'll just chuck that in there. We just got to find that next to the structure so we don't lose it. So OS thread, logic thread. Cool. There we go. So that's going to boot up a logic thread. Nice. So now we just got to move stuff over there somehow. So there's a game render. So I guess maybe we can start on the game render side, right? So the basic idea is game logic produces data and then, it produces a payload. So, well, how much of this gets, so the input needs to be, the events need to be iterated. Yeah, read windows. Yeah, why is that not red? Oh, so it can read the latest windows, I think. Yeah, I forgot why I did that now. Oh, yeah, because the UI could open up. Okay, so all of this code basically needs to be moved, including this really. Yeah, all of this. Now, you might want to update like the mouse cursor and that later on as well, so you get a more up-to-date mouse cursor and stuff like that. We need to figure out how to do that. But for now, cool. So game logic. Okay, so we poll completion on the asset system. Iterate through all the events, pick up the latest events, then read them into the OS packet, take a snapshot of all the latest state. Then calculate the delta time. It's talking about this sort of update camera thing, whether we update the camera or not. Render some UI. Now the payload, right? So we basically want to, yeah, so here's the thing. So you might want like a third one then, I don't know. Because, so the renderer renders, yeah, I think you need three. Three payloads. So the renderer owns one and the game owns one. And when you mark the game saying I've done with one of my payloads, it can then leave that queued up for the renderer to switch over to basically, but the renderer is still holding the other one. So yeah, that's the basic idea. Now, logic. Now we need to figure out how so snorkeling is not legal depending on the jurisdiction, because if it were, illegal background checks would also be illegal. Right. Right. Okay, so how are we gonna, I guess if we draw it, it'd be easier to think about it. So essentially you can have 3 payloads, right? So 1 payload, come on. 1 payload, 2 payload, 3 payload. So payload is basically the end of the frame, we just write a bunch of data in there. And then the um hmm. Yeah, this is fun. Cool. Right, so through payloads use, so maybe the game owns this one. Right, the renderer owns this one. Obviously this is index 0, 1, 2, okay? So the game writes out the render data, and then when it's done, it goes and finds the next one of these to use. So actually the renderer is owning nothing at the moment. Yes, I think we'll have some indices, I think. I think that's the way we're going to do it. So the renderer won't be on anything at the moment. But yeah, the game will... Yes, the game issues out something like this, right? And then it sends it to the renderer, so the renderer then puts index on here, right? Then the game moves over here and does its one by writing out another one. And when it's done here, it will go to the next one. Now, when the renderer is finished, it can then move on to this one because this one's not owned anymore by the game. And this one will become empty again to be used. So we'll probably need just a couple of indices basically dotted about. So you'll have your graphics, payload, game index, so logic index, and then render, or yeah, basically. So for these guys, you could probably say, so since there's only 3 anyway, like, or you could just have a bit mask basically, and what would you do? So you would just say, so the game logic is just trying to find the first 3 bit. Yeah, maybe that's all you need is just a bit set. And then the game just wants to find the next 3 bit to use, and it uses that one. Then the renderer wants to actually know an index. Right. It wants to know the latest payload ready index. So when the game is done, it's like, oh, this one's the one which is ready, right? And just puts the index down. Then the renderer, when it starts, it can say render index. Yeah, I think we'll do that. Okay. So ready index and render index can be equal to U32 max, right? Maybe. These might have to be atomic. So the render index, this will have to be an atomic. And anyway, it doesn't matter. Okay, so we'll initialize these guys to ggame U32 max, I think. Right, so when the game logic is done, yeah, I wonder if there's a better way to do this. So you essentially have 3 different slots. The game wants to find, out of all the slots, which one is not being used at the moment. So you could have a bit set. But then that would be like an atomic bit set, and it would kind of be... Yeah. So it just wants to read the bit set and be like, well, this one's not being used. And then you want to also... I guess let's write this down. So the game wants... So what operations do we need? The operation needs to be find next free payload. The other operation is, so the renderer needs to basically claim ownership over a payload. So the game would have been like, this one is the latest ready one, right? And then the renderer is going to be like, I'll use this one. So it... Yeah, so I think you need like... an own bit set. And then maybe a ready index. And... I think that's what you want. Alright, let's try this out. Right, so the game, when it's trying to do its thing, it's gonna do an atomic load on the ggame dot owned bit set. So it's gonna look at what's owned, and it wants to find the first free. You want to AND the 3 bits, and you want to find the first so bit, least significant bit, which is not set. So not the bits. And that should get you payload index. Now this can technically be, so assert if it's equal to so here we're saying game logic could not find a free payload. Cool. So we could pass out the payload bits. There we go. So say that for now. So when it finds the payload, it wants to so the renderer is never going to say, it's never going to take a free payload, or is that right? I could do. Yeah, so maybe you want just a mutex on it, but yes, I think you want to basically claim it at this point. You probably want a function to say claim yeah, so I guess you just do a while loop basically. What you're looking at doing is something like this. So compare exchange week. The address would be this guy. It's expected to be bits. And the value we want to make it now is bits board with 1 shift left payload index. Okay. Nice. So if that fails to compare and exchange because the value is not equal and the render thread took 1, it's going to go back around. It's done a load already, I think. Hang on a minute. Pretty sure it does a load. For crying out loud. So otherwise loads the actual contents into the memory pointed to expected. Good. As we expected. So let's leave it there. Cool. So when this is done, it wants to store atomic store into ggame.graphics payload ready index. That'll be graphics payload or payload index, yeah. Okay, nice. Cool, so that would be nice. Now, in the render side, so render, we want to obviously get the payload. So how do we do it? Well, we find that code again. Probably this code. And we tweak it a bit. So we kind of have like an expected payload index that we want, right? And we're trying to, there's a ready index, isn't there? So we want to load from the bits, the owned bit set, but our payload index that we want to use is actually an atomic load of ggame.ready index, right? The one the game set last time. Now, if the payload ready index is equal to U32 max, then we haven't got a frame yet. So we just keep on spinning. Yeah. So we keep spinning. Now, yeah, that'd be fun. So it's going to heat up the CPU for a bit, but it'll be fine. Now, payload. We get rid of this. So the next thing is we compare and exchange. Oh, we forgot to remove the bit set, didn't we, in the other one? Whoops. Let's go back quickly. So we need to actually do an atomic bit and. So we store the ready index there. We do an atomic fetch and. Yeah, an atomic fetch and. So we're going to and not. So we release ownership of this payload now from the game logic thread. Okay. So I think that's all right. So the renderer is going to load the owned bits in, load the ready index. It's going to try and claim the ready index. So how can it do that? So it checks the bits. It goes if bits and one shift left payload index isn't, if that's set, well, we continue because it is already owned by something and we can't take it. So this must possibly be this could be when it's newly acquired at the beginning of a game logic thread, I think. No. Yeah. Yes, I think we only really want to go into this if our game I guess we'll have a render index as well. Right, so the game render index or the payload render index, if that one is not equal, yeah, maybe we shouldn't be doing this bit set thing, but it helps us find an available one quite easily. Yeah, we'll keep it. So the render. So when they're not equal, we should go into this basically. So if the render. Just make it a bit of a different value. Right, let's move this in a little bit more. So let's say if atomic load the ready and the current one we're using to render with if these are not equal, reverse into here. Okay. So we get the owned bits, we load from the ready index. If it's still equal to U32, then we haven't got a frame yet, right at the beginning. If first frame is not ready, then if the slot that we're trying to read is now, or trying to acquire, is owned, we'll continue again and load from the owned bit set. I think. Yep. So now the idea is we if there's anything using the render index other than the render thread, I don't think so. No, cool. So basically after it gets acquired, we need to make sure it gets set to payload index. Right, so now the idea is try and acquire it. If you can acquire it, yes, then go. Now, the thing is we have to write the code which removes ownership of the render index. So what we're trying to do is, okay. So the new bits, we'll call it. So that you want to be you want to acquire that, but then so you want to own this and then disown. So be an and not of that. Yep, and then you put your new bits in there, yeah? Right, this is one way of doing it, I guess. Feels a bit complicated, but we're probably gonna have to change this later if we did any kind of payload interpolation or something like that. But we'll see. But anyways, solves the problem, I think. So you fish yourself out a payload, and then basically you send it to, Oh, this is weird. That makes it a frame late. But yes, so then you render it, right? And then you may do the hotcode reload. Cool. So let's go back to game logic. We get in there. So game camera update, we probably need to stick that somewhere here. Okay, so I think that's basically it. You know, we've got to try and do some proper exit code, I think, and stuff like that, but I think that's in a good place. So let's try and run and see what happens. Right, we get absolutely nothing showing up. Good start. So are we stuck somewhere, I guess, is the question. So let's go there to start off the run. Well, it's not really a good place. Can I open up a file? What am I doing? Code, apps. No. Modules. No. Games, game C. So I want to go that logic thread. Right, do we get here? No. Apparently we don't even launch here, which is crazy. So where else do we do logic thread? Let's have a look. Apparently it's inside the game UI. Oh, it crashed. Whoopsie. Right, we didn't initialize the thread allocator, that's why. But like, how did you make it past the breakpoint? That's what I want to know. Did like breakpoints not work? What? But yeah, it seems like the thread. Oh, okay. Weird. I don't know why the breakpoints didn't work, but anyways. There we go. So we need to initialize the thread local storage. Let's just do that. Cool. Yeah, so that's another thing as well. Oh no. Right, so let's go here. Cool. So you run that. Nothing's happening, so right, so it seems to be issuing yeah, so it makes a request to open up a window, then it's waiting for the result, and it no happen, unfortunately. So where's the event thread? So we have this system where all of the events are made on a particular thread. What do we say? Yeah, all events are made on a... Yes, I think because the thread isn't made... Yeah, there's something really weird in Windows. So I've had to basically make the event thread inside the executable, but not the DLL, I think. Such that the lifetime... Yeah, it's all weirdness to do with how when you unload a DLL it deletes stuff. So... Yeah, the thread is made by the DLL. Sorry, made by the executable. And then it runs the event thread, which the DLL is. Then... this is why some of my stuff could be breaking. Oh, no, it doesn't. Right, yeah, it calls one of these functions, then it calls the... Yeah. Then we call the event thread processing, which is inside the game DLL. Now, if the game logic is not made by the executable, does that mean the get... You can't send a message over to it, maybe? Because what this open would have done is it's given... It does a request queue and an end. Which do a post message. And I think that doesn't work across DLL boundaries. Could be wrong. But maybe not. Let's see if we can Google it. So, does post message so I have across the DLL boundary. However, critical constraints regarding data you send. Right. Handles are system wide. The DLL can handle user handle from an exe to post that exe's message queue. Is asynchronous. It places a message in the receiving thread's queue and returns immediately. Right, cannot pass pointers. Right, CRT mismatches. UDLL, a different version of C runtime. Heap corruption, right. Right, so I think we can put a breakpoint in the event loop. I think. Because I went over it's actually going to fire, but it should have fired. So I don't think it's... Here we go, yeah? We'll stick it in. So, right, so it's firing. What message is this? I don't know. So, do I go to my... There's a few different procs, isn't there? I think. Anyway, let's just get in there with that one. This is the request proc. Yeah, there's a few of them. It's crazy. Right, so raw input, raw input, raw input, and then nothing. Yeah, so it seems like it's not going across the DLL boundary for some reason. Figure out why that is. So OS Windows is doing like a request queue end. So the request queue, you put it on this multi-producer, multi-consumer queue, and then we just send one little post message. And we're saying, hey, we've got a something we want you to do on the other side, basically the event. So it calls this one here, and it allows you to, you know, the request might be, hey, open up a window inside the thread which belongs to the executable, right, which was made when the executable booted up and not inside the DLL. So then the window belongs to the executable and not the DLL, which can get unloaded. Yeah. It's one of those things. So we can't send that message across for some reason. I don't know why. But I think it's because the render thread is made by the game executable and the logic thread is made by the game DLL. And this thing is wrong. Right. Let's see if we type it out a bit better. Let's see if it can help us find the solution in some way. So I have game.exe that calls into a runtime loaded game.dll function. Function the game.dll creates a new thread and calls this post message thing. That creates an event thread and then creates a new thread, calls post message, and the event thread that is made by the game.exe does not see the message. Let's say that. Let's see if it manages to find the information. It's most likely your event thread isn't seeing the message because it's designed to deliver messages to a window handle, while your event thread might be expecting a thread-specific message or lacks a proper message pump. So, yeah, we're doing it to a window handle. This message is delivered to the... Oh, interesting. This might not be a valid handle. because maybe the global is not. Yeah, so maybe what happens is this actually isn't a handle. Let's see that. Hang on. Right, let's get in there and analyze that. Is 0. I think 0 might be invalid. Let's see. So, wait a minute. Oh, we're trying to do a post before we've even made the request. Oh, where's the request HND made? Sorry, HWND made. It's made when you init, you do a thread in it, and that would have happened. Oh yeah, so let's go to a. Yeah, so maybe it's because again, this is a Windows thing, right? It doesn't work like this on Linux, but the global state is actually not shared across your DLL on exe boundaries. I think is annoying, but let's go here. Yeah, so run that. So it starts off as 0. Crap. What happened? Right, let's run that again. Oh, so the event thread is booting up. That should have been initialized right away. Isn't it? Yeah, it's stuck here. So, oh, because the game would have interesting. So the game initializes, makes a oh. Right. Okay, I see the problems. So we have an issue now where the game logic is being ran first and beats. Yep. So the game logic thread boots up before the event thread has actually been initialized properly. So it cannot send. Okay. So maybe then the game logic thread needs to be booted up inside. Right. Where's game render? Yeah, so if g game dot logic thread. Not sure we can know if that is null or not, but basically, if it's not running, somehow we need to know that. So there's like a payload render. We want to know if this is the first frame, basically. So I guess you save the ready index. Maybe we need some specific how do we know if someone is null? Right, so I want something like that for the thread. So, I think for the thread, so for Linux, I think it will be pthread t, isn't it? I think. I don't know. We'll just do 0. Could be wrong though. But for Windows, it'd be a handle. Let's double check my Linux things. Pthread. Yeah, 0 in it. So what's a pthread t? So Linux is 8. Just do a 0 to that, I think. Cool. Nice. Right, so we can now know whether something is invalid or not. So here we go. So if core compare element, so I want to compare G game logic thread. Now the issue is though, that isn't going to be equal to invalid right away, but it will be right. Make sure you initialize that to invalid. All right, here we go. Then kick it off. Think that'll work. Right, needs an address. Right, stack is not initialized yet. Where's this? So game C. Oh. Packet clone. Cool, I think we made progress. So, yeah, game logic thread, it is run. Oh yeah, because the window booted up. So I think we solved that problem. So basically this we need to initialize these. So inside the graphics, we actually want to initialize the packet payload in there. Right, here we go, come on. Nah. So it's got a white window for some reason. I don't know why that is. So let's check the render. We know that works. So the logic thread is going to be pumping stuff out, I reckon. Double check that here. And render is here, yeah? Yeah, so payload is the null value, right? It just keeps spinning, yeah? Cool, we'll leave that alone. We'll put that there. what's made a window, we're good. So then at the end of a frame, it's gonna say the one that's ready to use is payload index 0. And we're gonna OR out one shift left 0 not. Sorry, and out. Yeah, so it's no longer owned. Cool. Right, so where's the render? So render should be looping around here now. Oh. Right, so that would... Right, I think you got it. Not sure, yeah, payload index 0, so it would have done a render, yeah. Not sure how well that is, but let's see. So it's just got a white screen though. So I think what this could be is maybe the Vulkan objects are not being rendered. Like maybe it's to do with the Vulkan objects. They're made on a thread which is now not part of the executable. Maybe. So Vulkan objects can safely cross between an exe and DLL boundary in the same process. Right, this one's going to be a bit of a weird one to find. But yeah, I guess we want to put breakpoints in like, you know, does it present a frame basically sort of thing? Do you get down to there, right? Do we do a UI render, right? Yeah, so maybe maybe it never acquires any. Yeah, okay, so it's never able to acquire any surface to render to. So it's getting most of the way there. So the reason why it's probably not doing that is because something to do with the window IDs is wrong. Yeah. They're just not. Okay, so yeah, it's all kind of like zero data. So right, this is a problem. It's trying to reinitialize the data back to 0 again, not good. Not really the problem though. So you do a clear. Right, so we can just print out logic on a certain payload. Alright. And then game render. So we're going to say, hey, we're rendering. This payload here, yeah? So what do we see? The logic runs like tons of times. Keeps saying 0, 0, 0 while the render is also saying 0. That's a problem. So they're not sharing properly. They are actually obtaining both the same slots. Cool. Why would that be? So the logic is probably the logic is the problem. So I reckon the logic when it acquires, it's not saying, yeah, it just ors it, right? It's not doing the check like this one. Saying don't take it. So don't take it if it's already owned by someone else. Right, so the logic is operating on 1, and then the renderer operates on 1, and the logic operates on 0. Yeah. But do we ever get a different number though? Like 2? Because the way it should work is game renders, issues a payload. Renderer acquires that payload, while game looks at another one. And if the game is still on that one, the renderer... Okay, sorry, then the game finishes and issues another one to be used. Yeah, we might see it. Yeah, so the game could have done this one. Right, so let's just say the game's done this one, then the renderer will start reading it. Then the game goes here. The renderer... Right, so the renderer is still going with this guy. And then the game gets done and moves on to another one. Right, but what's happening is R1 is going back to here and using it. But then maybe... But how's it able to do that? When... Right, so the moment the render switches, it's going to own and disown 2 indices. It's going to own a new one and disown the other one. Oh, yeah, okay, I think that's the problem, because the logic keeps grabbing the same one again. There it is. So the game logic... The game logic should be... Yeah, so it shouldn't disown it here. It should say that one's ready. Yeah, so I think you want to take out the... Yeah, I think this logic could be better. Yeah, so the game loads in the bit set, gets the least significant bit. You could probably take out... Super bad, but okay. Take out the ready index from that list. Such that it will use a different one. But you only really want to do that if there is a ready index. If ready index is not equal to U32 max. Yeah, we could probably write this code up way better, but for now this will be fine. Just get it working the way we want it to. Right, so this point the game, the render, the logic would have... Yeah, so the renderer would have said, hey, I'm using 0. So the renderer will say it's using 0. So that's in there. Zero is ready. So you just would have said 1, not of 1 would have been everything else to keep. Mm. Right, let's do that one there, innit? See, maybe it would have been better just with 3 indices or something. Right, so the bits are 1. And then what did it get in the end as well? Payload index did it get? Right, maybe because it knots the bits here, so it would have been... These are the bits which are owned. Yeah, sorry. Right, I see it now. You actually want to OR it to pretend that it's owned already, something like that. Alright, let's give that a go. Cool. That seems to be doing what we want, where it's switching between the 2 different available payloads. Where it's altering between the two different payloads, and then the renderer goes, hey, I'm taking number 1 now, and then it alternates, right? That's the behavior that we want. But yeah, the code is a bit weird, but it will do. The problem is, though, obviously, we still have a white screen. Oh. And apparently we get a crash. Right, so there's a thread problem as well. Okay. So we'll fix this tomorrow. So I'll be on Friday, 2 p.m. GMT plus 1. We'll hopefully wrap this up and have this sort of, you know, the game running on a separate thread to the renderer. And that'll be pretty cool. And then we can hopefully move on to some other things. But yeah, just a quick reminder, I won't be on from this Sunday to next Sunday, including all of those days in between and those days at the end. So I won't be here 10th to the 17th, including those days, because I'm going on holiday. I'll be back after that. So tomorrow's my last stream for like a week and a bit. But in the meantime, guys, Discord channel, and thank you for everyone who supported the channel. And if you wish to support the channel as a way to get access to the codes to run on your own local machine over at that link. But yeah, appreciate you all. Hope you have a good tomorrow or weekend. Hopefully see you tomorrow. If not, have a good weekend, guys, and yeah, good night. God bless you all. Bye bye.